We're going to use Desmos.com online calculator to come up with a power function that will approximate the Lorenz curve for calculating the Gini index. So we're going to start out with some data that was from the US in 2010, and we're going to use that to come up with an approximate Lorenz curve using both the power function, and we're going to go ahead and try also a quadratic function and see if one of those maybe gives us a little bit better. Okay. All right, so first thing we need to do is we need to write down in the right-hand column the cumulative percent of total income in decimal form. So for the first group, that lowest 20%, we're just going to go ahead and use 0.033. Okay. And notice that the lowest 20% would be 0.20. And then when we add in, so this would be the lowest 20%. And the second 20%, now when I add these two together, I end up with 11.8%. So that's what's going to go here, 0.118. Now when I add 14.6 plus 11.8 together, that's 26.4. So that goes in the next spot. And then when I add 26.4 and 23.4 together, we end up with 49.8, and that goes in this spot, 0.498. And then last but not least, we should always end up with 100% or 1.0 for the total cumulative percent, because now we've got all 100% of the population. That should accumulate for account for 100% of the population. So I want to keep these in mind, so write these down somewhere so that we have them for the next screen when we go to plug these into Desmos.com. So that's where you want to go to next, DESMOS.com, and click on Start Graphing. Okay, so we're going to take that data we had from that previous table and we're going to put it into Desmos. So the easiest way to do that is to tap on the plus sign or click on the plus sign and choose Table. And in X1, we're going to type in 0.2, enter, 0.4, enter, 0.6, enter, 0.8, enter, and then 1. Okay. In the other column is where we're going to put those cumulative percentages. So they were 0.033, enter, 0.118, enter, 0.264, enter, 0.498, enter, and 1. Okay. Now we'll notice over on the right-hand side of the screen that these are all kind of bunched up. We can't really see a whole lot of detail. So that's easily fixed by clicking on this shape over here. Let's see if we highlight it over here. Okay, what we're going to do is actually click on that, tap on that, and that brings up some settings that we can change. So the first thing is I'm going to change the settings for the x-axis. So instead of -10, I'm going to type -0.2, and for the maximum, I'm going to type 1.2. So this is going to adjust my view of the x-axis to between -0.2 and 1.2. And then same thing for the y-axis, -0.2, and the max to 1.2. Okay, and then click on it again, and now you can see our plot a little bit more clearly, and we can see the axes in each direction. Okay, so the next thing I want to do is I want to type in the line y equals x. Y equals x, but I also want to restrict it to just between 0 and 1, because that's really all this data is representing, is between 0 and 1. And so the way that we do this is by using the curly braces, and 0 less than x less than 1, and close my curly braces. And notice now it only graphs it between 0 and 1. All right, So now the next thing that I want it to do is to use what's called a power regression to approximate the Lorenz curve. And once we graph this, you'll see it's not a perfect Lorenz curve. The Lorenz curve actually goes through each and every point. And it takes quite a bit of high-level mathematics in order to find that curve that goes through each and every point. And for our purposes, a power regression will be close enough for us to do our calculations. Okay, so the next thing I'm going to do is type in the next box. And I'm going to type y1. It automatically recognizes that I want y1 because I've already used y1 up in the table. The next one is not an equal sign. I want to use the tilde symbol. So this tilde symbol in geometry used it for is similar to, that sort of thing. And now I want it to come up with its generic or a general regression formula. So I want to write ax1 to the b. So a is the coefficient, and then I want x1, and then I want to raise that to the b power. So you can either use the caret function, just like you would on your calculator, so shift in the 6, or you can type on the a to the b, and then type in b for the exponent that you want. Okay, and here we can see this function. Okay, so this area that we're looking for, this area of inequality, is this area right in here. And you can see that our power function doesn't quite go through each and every data point. Okay, it's approximate, comes close, but not quite each and every data point. Okay, so in fact, we're going to go ahead and use this. So what I'm going to do is on my paper, if I'm doing my project or whatever, this is going to be y equals 0.984 x to the 2.693. And that's what I'm going to use for my approximate Lorenz curve for my project, for other problems that I might do out of the textbook or homework or things like that. So notice with Desmos, this is pretty easy to do. The key is using the y1 and the x1 so that it knows to use the data in this table, and then the tilde that tells it to do a regression. And that's pretty much it.